with a talk from Julien, Michel from CNES about the new features of Orfeo Toolbox. The floor is yours, Julien.
Good afternoon, everybody. So my name is Julien Michel, as Evan said. I'm with the French Space Agency, and well, I'm presenting today, but there are many people working on this project, so it's on their behalf. Okay, so the talk is what's new in Orfeo Toolbox, but since we don't have the notoriety of maybe GDAL or map server, it will also be about what's Orfeo Toolbox and how you can use it. Orfeo Toolbox, what it is, it's an image processing library dedicated to remote sensing. Of course, it's free and open source software under an Apache v2 license. Funded and developed by CNES, but not only by CNES. We have, project steering committees, contributors. So it's not a CNES thing anymore. Now it's used and contributed to by many other people. I'm proud to say that we are an official OSGeo project since 2017. So that was something. It's used at CNES by ESA. On mission exploitation platforms, in remote sensing labs for teaching, and all kind of stuff. I will show you some example during the talk. It's written in C++ on top of ITK, which is, it's also a toolbox, but dedicated to medical image processing. And of course, we are using extensively a lot of other OSGeo or non-OSGeo open source software like GDAL, of course, OSIM, OpenCV, MuParser, and all other, a lot of other softwares. So the distinguished thing about Orfeo Toolbox, it's that it's made to be, I would say, I didn't write scalable because it's big data capable. It means that you can do the processing with big data on your laptop or on a cluster, and it will run smoothly, okay? And this is because we have things that I won't go into details now, which are streaming and multi-threading. So you can go on our website, orfeotoolbox.org, and find out more about that. Okay, so I'm not sure I need to argue for this slide here, but this is an extract from a wider presentation we usually make. Why do we do open source software with Orfeo Toolbox? The first point is maximum reach. We want, as CNES, we want satellite images to be used. So we want to provide the tools to user to use those data. So open source is a way of reaching a maximum number of users. It's also for quality and efficiency because we cover a large panel of application, thematic fields, algorithm, and so the idea is that we cannot test, validate every use cases. So we can, with an open source code, we can rely on users to, to validate further, to contribute bug reports, documentation, and enhancements, and so on. So this is one of the important points here. And also we are using OTB to make reproducible research. I mean, we are sometimes publishing papers about new methods that we implemented with OTB, and we can then say, okay, look at those results, and they were obtained with this code. You can try it at home with your data and report if it's working or not. So this is also something quite important. So I know it's the afternoon already. Everybody's already maybe tired, so I included a few pictures in my presentation for you to relax. So this is a Pléiade image over the island of Mayotte. This is another one of the same area. They were superimposed with Orfeo Toolbox, you can see. And so this is the result of an algorithm we called MAD. MAD is for multivariate alteration detector. And MAD will provide you with different changes indicators that are not correlated with each other. So it will give you, a map with different changes that you can further interpret in a machine learning system or something like this. And this is, of course, everything here is computed with Orfeo Toolbox. So you can see the things you can do with Orfeo Toolbox. This is another nice algorithm when you work with very high resolution data. It's called, it's called line segment detector, or LSD. Okay, and yeah, it detects lines. Okay, so you can see that on the building it's quite efficient with not so many false alarms. So you can do this with Orfeo Toolbox, of course, and I would just like to say that you could go to the original research code, which is also published under an open source implementation. But what OTB will bring you is that it will allow you to compute this piece by piece, so you can process a very large data, which the original code cannot do. And also, it will write the output to a shapefile, geocoded shapefile, so you can directly import the output in QGIS and see and start working with it, which obviously the original research code doesn't do either. Okay, moving on. So this is another Pléiade image on the Argentière glacier in the Alps. Actually, there are two images with a slight, slight change of viewpoint. And Orfeo Toolbox can also do this for you. So if you have your red and green glasses, now it's the time to wear them. You would see the glacier in 3 dimensions. This is another thing that OTB can do for you, segmenting. Actually, we come to that in the last slides because we have some new developments here. But you can see this is the mean shift algorithm, and it's computed at a full image scale with exact results, and you can compute it piecewise with exact results, which I don't think many software are able to do right now. Okay. This is another interesting feature. It's the sample selection framework to do machine learning. So you provide, polygons which are your reference data, and then you want to train a machine learning model to classify the pixels according to the labels of the reference data attached to the polygon. So actually, the sampling framework allows you to select points inside the polygons, and say it allows you to do it with a fair sampling. I mean, you can choose if you want all the classes to be sampled with the same amount of samples. You can also be sure that you didn't select all the sample in the first polygon and then skipped all the spatial variety of the remaining of the reference data. So Orfeo Toolbox allows you to do that. You can then feed the sample data, which are shapefiles that you can check on QGIS once you generated them, to another tool to perform the classification. So you can use this to derive land cover maps, for instance, from Sentinel-2, and I will also come to that later. Another thing you can do with Orfeo Toolbox, and this is quite new also, is let's say this is a Sentinel-2 data. Let's say you want to publish this, I don't know, a map or a blog post or something like this, and it's not really pretty, right? It's very saturated, and you don't see many things in the shadow part or in the water part, and we can do this, which I think is much better for visualization purposes, of course. This is the contrast limited histogram equalization that you can do locally, and it enhances, the contrast, and you can see all the details in the imagery. And you can also do that with Orfeo Toolbox. So this is just a few, examples of what you can do. More importantly, I would like to present how you can do this. So you can do this in Orfeo Toolbox. There are 3 main ways to use the tool. You can start with the full API. So this is you have access to everything. So this is C++. It needs a bit of knowledge of the language, but you can do. You have access to all the functions. And then we have another level we call OTB applications that allows you to, it's tools that are developed on top of OTB that allows you to perform classical tasks like auto-rectification, classification, segmentation, feature extraction, okay? And those tools, I will come to that later, but you can call them from Python, from command line, from an auto-generated Qt interface, from QGIS, from Monteverdi, which brings me to the top level of this chart. This is a small visualization tool we developed to quickly browse images, and you can also, and of course, you can call all the application from this tool, so you can access. So the end user will go for this. Most people use directly the OTB application, and if you want to develop some new OTB application, you will go for this level. Okay. So how does it look like? Show me the code. So this is the C++ API level. So it's not that complex. I mean, you're defining some object like a reader that you are chaining to an edge detection filter and then to a writer. And then when you call update, everything synchronizes and you got your results on the drive. Okay. Now, if we come to the applications, the idea is that you write the code once and you can use it everywhere. So the concept is that one application is compiled in one dynamic library, and they are auto-descriptive and auto-documented. It means that you can ask to an application, okay, what are your parameters? What is the limit of this parameter? What is this parameter optional or mandatory? And we can use this to develop plugin players like command line or Qt auto-generated or Python, okay? And you can write your own applications and share with others, which is also important. So we have a lot of applications shipped with OTB to perform all kinds of remote sensing classical tasks. This is what it looks like. Okay, this is the auto-rectification application called from command line. Okay, so you can see you have all the parameters. It gives you the missing ones. Of course, you have documentation. You have even more documentation than that, but it's just the compact view, you know. And if you want to do the same thing but from Qt, then you go for the Qt interface, and you have exactly the same field. Actually, when you write an application, you don't have to write any code related to the Qt interface because it is generated automatically from the application. Okay, you simply say, okay, I have a parameter that's called input image, and this automatically appears here. Okay, but what is really important to remember is that you run this or this, it's the same code that runs. You have the same performances, you have the same bugs. So if we fix one bug, we fix it for all interfaces. And of course, you can also call applications from Python. Still the same code running, but obviously it's a different way of calling it. So this is exactly the same code, the same application, but this time called from Python. Okay. So now let's have a look at Monteverdi, which is the viewer. So in Monteverdi, you can load several images, browse the stack. You have some nice rendering tools based on GLSL. So it's quite nice. And here you have the list of applications, and you can put one layer into an application, run it, and then you get a new layer, and all this kind of mechanism that you also have in QGIS processing framework, for instance, which is a perfect transition. We are also in QGIS processing framework, but I will not say much about it here because I have a dedicated section coming right now. Just to say that you can extend it and include OTB wherever you want. For example, you can also call the OTB application from a Zoo WPS service. So it's really, the applications are meant for integration of OSGeo Toolbox in other software or services. Okay? So now this was the what's OTB part. Now let's go to the what's new part. Okay. So what's new? We want to make OTB in QGIS great again. I'm sorry about this formulation. It's my colleague who wrote this slide. So we had, we found evidences of QGIS, OTB QGIS plugin in 2009. It was like, a dedicated code running. And then, of course, we developed the application, and someone said, okay, we need to have those applications in the QGIS processing framework. So this was done in 2012, I think. We had the first version here. And it's a powerful wedding because it facilitates access to OSGeo Toolbox, to the GIS community. And it's also avoid to duplicate efforts. Like, for instance, in Monteverdi, we will never develop the feature to draw polygons or to select shapes or things like that. It's awesomely done in QGIS, and it's hard to do. So it's better if we could just benefit from what's already in QGIS. Also, there are some obviously powerful features in QGIS processing, but I think there is a keynote about that later on. So we'll see that. And well, this is very, very positive, but everything is not that simple because the way things were done in this first plugin version make it quite difficult to keep the QGIS plugin and OTB synced. The QGIS plugin was not working with all the versions of OTB. The applications were split because we were missing some components in the processing framework to represent, for instance, group of parameters that are optional or things like that. So in the end, it was not that good, at least from my point of view, and we had many users just giving up, so that's bad. So we decided just this year that this could no longer last, and we need to rework this to get a proper integration. So we have a new version of the OTB QGIS plugin, which aims at supporting our binary installers in QGIS out of the box. So you just download the OTB installer, you install, and it's working in QGIS, no matter what version you have installed and all that. You have all the OTB application without any changes to the name, to the documentation. It's the verbatim copy of what you have with other interfaces. And we are compatible with QGIS 3.2, and we hope that the new plugin will soon be added to the QGIS source code. In the meantime, you can just go there and test it. And we had a lot of exchanges with the QGIS team to get this on track, and we would like to thank them for that. So hopefully, in a very near future, we will have now some OTB plugin in QGIS, thanks to all this work. Okay, so this is how it looks like. So this is the configuration screen. You just say to QGIS where you installed the binary package, and that's pretty much it. And this is the GUI of the smoothing application, and this is the GUI of the train image classifier application, which is quite complex. And you see there are some. No, it's not here. Here you can see you have this. This combo box that allows to choose different modes, and it will change the parameters set you can configure it. So so this is what was previously missing, but we added it. Okay, so this was about QGIS, and now the last part of my talk will be about remote modules. What remote modules are? They are pieces of OTB code, like filters, classes, applications, that can be hosted on someone else's Git repository with a different license and intellectual property, and while still being tested and packaged within OSGeo Toolbox. So actually you can develop your own features and be packaged in Orfeo Toolbox while still, getting your hands on your code. And people are using them very much as a standard way to package new features to share with others. Like it can be small modules with only one new application, but we also have full processing chains in Python relying on one or more remote modules. So I have a few examples here. So we are often asked the question, okay, but do you do deep learning? So I can say, yes, we do now. Thanks to this guy, Rémi Cresson from IRSTEA, he contributed a remote module, which basically interfaces Orfeo Toolbox with TensorFlow, and it provides all the plumbing to perform deep learning based on image processing for remote sensing images. You can generate training data from large satellite data sets. You can train your network or do it directly with TensorFlow, and then you can serve the model on full remote sensing images using OTB streaming and all the nice mechanism we have. So this is an example. Another example is the segmentation module. This is a remote module funded by CNES with contribution from Rémi also. This is something we did with a PhD to do base and shape segmentation tile-wise, I mean piece by piece, with an exact solution. I mean no monkey stitching, because usually those softwares, they do piecewise segmentation. They try to stitch at the border to make things work. But this is not how it's done here. Here it's an exact solution that's implemented, and it runs on a cluster thanks to MPI-based communications. Okay, so you can see an example here. This is a full image of Pléiade image of La Réunion Islands. It has been segmented in 16 minutes on 32 cluster nodes. So actually, we do need a cluster to do this if you want to process things in reasonable time. And so we extracted 3 million polygons from these images. You have an extract here. And this, you can open this directly in QGIS. Okay, but 3 million polygons is a lot, but you can open this directly in QGIS. So you start with your remote sensing data and you end up in QGIS. But you also have full processing chains, like Let It Snow. This is, okay, 3 slides left. So this is a processing chain that extracts snow mask from Sentinel-2 products. It's a code from CNES, SBU, and CNRS, and it's used for automatic production on selected sites here. They derived more than 10,000 products. Okay. We also have IOTA2, which allows you to generate country-scale land cover maps using the machine learning, the sample selection framework I presented earlier. So they take 1 year of Sentinel-2 data over the whole country, and they derive a 20-meter resolution land cover map. So you can see here. All done with Orfeo Toolbox on CNES HPC. And we are also working on a module to perform SAR interferometry with Sentinel-1 data. So this is also a work in progress. I come to my conclusion. So what you learned is, I hope you see what OTB can do for you, even if it's incomplete. I encourage you to register to the Friday morning workshop if you didn't already register. I think there's still room for new participants. How to use OTB. The take-home message is we are committed to make OTB in QGIS better. Remote modules are a standard way to package and share OTB code. And we have really interesting new features that comes from various contributors as remote modules. And in the future, big changes for OTB 7.0. I don't have time to explain that, but okay. More amazing remote modules, and of course, all the issues opened by the user. Last slide. We have user days in Montpellier in France. You're welcome. It's free. Please come. Okay, thank you.
Thank you, Julien. we have time for one quick question. Yes, please.
Yeah. In fact, Maya is based on OTB. It's written in OTB. We are still, fighting with. I shouldn't say fighting, but trying to convince the people that wrote this code that it will be better to have it as open sourced. Yeah, it will be great. So, any other question?
Okay, thank you, Julien.